project. India has the fourth largest network of trains. 20 million people travel daily by rail. But safety remains a pressing issue. Derailment of train due to disaster, bandit crime, overheating of steel is a serious problem. If you look at statistics, from year 2011 to 2014, 310 trains derailed, causing a huge loss to man and material. In our project, train acts as transmitter, which produces vibrations. Vibration sensors are attached on the railway track. If vibration sensor receives vibrations below a defined threshold, Zigbee transmitter will send this information to Zigbee receiver, which will cause the train to halt. The same information is also sent to base station. We also have an ultrasonic module for minor crack detection. Look, there is no derailment here. The train is moving constantly on track. Vibration sensor has some output and so the LED is blinking. There is derailment here. When vibration sensors stop receiving vibrations, the train stops and the LED of MSP glows. And the same information is sent to base station. The probe produces ultrasonic frequency. As soon as we click on read and save data, we get graph. We will observe graph when there is no crack. There is a crack here. We have the same arrangement. Now we will obtain the graph and compare the two. There is an extra peak in the graph when the crack is present. We have a Texas module PGA450Q1. This is the EVM board and this is the Tiger board for communication with PC. USB cord connected to the system. This is ultrasonic probes which emit ultrasonic waves. We have adjusted all the ESFI registers according to our need. We have loaded the hex file in the EVRAM tab. We have done the evaluation tab settings and adjusted LIN. As soon as we click on read and save data, we get graph in Excel. Let us once again look at the graphs. If there is a crack, there is a peak. On x-axis is the distance and on y-axis is the voltage. Echo signal is converted into electrical signal. Let us see what actually happens. When wave travels through solid, it encounters a medium change, it reflects back, which is given as peak. We have placed our probes on the surface. Theta came out to be 10 degrees, so we have placed a wedge which introduces the wave at 10 degrees in the medium. When there is a crack, you will get the label distance. Knowing all the values, we can calculate the value of distance from the starting point. This is the transmitter model. It consists of a vibration sensor, a Zigbee Series 2 module, Texas Instrumentation's low power MCU named MSP430G2553 and Texas Instrumentation's voltage regulator IC 7805. MSP430G2553 is a 20-pin controller. It supports 1 UART, 1 SPI, I2C and has a clock frequency of 16 MHz. The vibration sensor and Zigbee module is interfaced with G2553. The vibration sensor is a device that senses the vibrations and gives the reading according to the vibrations. It consists of 3 pins, VCC, ground and data pin. Also the sensor contains a potentiometer through which its sensitivity can be adjusted. The data pin of this sensor is connected to MSP, which gives input to the controller. When the input through the data pin is below a threshold level, MSP sends a command to Zigbee through UART transmission. This is a Zigbee Series 2 module which works on mesh networking. It has 20 pins, it is interfaced with MSP through UART, that is Universal Asynchronous Serial Transmission. This ZigBee is configured as coordinator which sends signal to receiver ZigBee part after it receives a command from MSP. This is the receiver model. It consists of Texas Instrumentation's motor driver IC named L293D, a ZigBee Series 2 module, Texas Instrumentation's low power MCU MSP430 G2553 and the motor of the train. The L293D and ZigBee is interfaced with the controller. The MSP G2553 is similar to one used in the transmitter module. Also, the ZigBee is similar to the transmitter except that here it is configured as the router. The motor driver IC L293D is driven by the controller. It is 16-pin IC. When no signal is received by the ZigBee router, the MSP enables the IC and the train starts. As soon as the signal is received by the ZigBee, it sends it to MSP through UART. The train is stopped through the IC. Since it is a prototype, so L293D is used to drive the train.
The base station receives the information of derailment from the train. For facilitating this, we have Java-based module in combination with HTML CSS for UI that displays the latest crack detection on the rail over a network, providing the address of ZigBee for crack location. Machine having the output file acts as a client and the updates are visible to the server connected on the same network. Running the admin module on any of the connected machine is a must to start updating the tables.
Let us look at the power supply. We have given 12 volt supply to PGA 450Q1, 3.3 voltage to both ZigBee in receiver and transmitter model, 5 volt is given to MSP G2553 and 9 volt is given to L293D. 5 volt supply is given to vibration sensor.